Hello, welcome to the Science for Policy podcast. My name's Toby and today I'm joined by Professor Karen Yeung. Professor Yeung is Interdisciplinary Professorial Fellow in Law, Ethics and Informatics at the University of Birmingham in the UK, where she works in both the Law School and the School of Computer Science. She focuses particularly on the regulation and governance of AI, and as her job title suggests, her work spans many disciplines, including physical and social sciences, engineering, law, and the humanities. So, Karen, welcome to the podcast.
Hello, Tony. It's great to be here.
Hi. I'd like to start off by asking you a general question about artificial intelligence. And you can think about large language models, or you can think about other forms of artificial intelligence if you want. My question is, what are AI's current capabilities? What's the state of the art right now in terms of what it's really good at?
Well, it's a great party trick as far as I'm concerned. So it can do really cool stuff and people get really impressed. So I think in terms of public perception, it seems to do really amazing, whizzy things. And I have to be honest, when you use a generative AI tool, even I go, actually, that's pretty cool. So in terms of text and image generation, it's doing quite extraordinary things that we haven't seen in terms of technological capability before. But in order to get a little bit more serious in terms of concrete applications that might be useful to us, certainly we're seeing pretty major disruption in the creative industries, for example, because of the quality of new kinds of content that can be created through the use of AI tools, but because of the capabilities of data analysis, we're also seeing real advances in the production of new insight and new knowledge across a range of fields, but some disciplinary fields are more amenable to using that capability than other kinds of disciplines.
Okay. I mean, you started off by calling it a party trick, which is kind of a little bit damning. I wonder if you could drill down a bit more into the different scientific disciplines where it is being used or might be used, and perhaps also where it's not so useful.
Well, in terms of scientific discovery, there are fields where we have massive amounts of data, where I think that AI is making really significant advances in our capacity to generate new knowledge. So, for example, in the physical sciences, particularly thinking about genetic data, which is massive. Also, in terms of astronomy and understanding time and space, our capacity to analyze patterns generated from data taken in those spheres, and also in medicine, data generated from the human body. There's enormous capability there to scale our analysis of data in a way that we haven't had the capacity to before. So in those very data-rich, data-intensive fields, we're seeing pretty impressive strides, I think, in knowledge generation and insight production.
Yeah. It strikes me what those fields have in common, apart from having massive amounts of data, which is obviously a big feature, is that they're also fields where we already know how to do discovery. Like discovery involves processing information to notice new things. It doesn't necessarily involve like new conceptual discoveries.
That's exactly right. So a nice example is Google's capacity to identify protein folding mechanisms by simply applying AI tools. And it was a perfect task for an AI system to undertake because we understood how to generate this knowledge, but it was incredibly task intensive. It required an analysis of vast amounts of data that we simply couldn't apply ordinary computing to in order to speed up the process to generate the kinds of insight that's now possible because of these tools. So it's those kinds of scientific tasks where serious advances have the most promise, at least in my view.
Yeah. But the examples you've mentioned so far are kind of pure research examples, though. You're trying to crack a hard research problem. If we're talking about policymaking, I guess I really mean scientific or knowledge-based contributions to solving policy problems. Are there problems also in that area that sit at the intersection of science and policymaking, which are also amenable to this kind of improvement that AI could drive?
Well, certainly in my view, there are massive challenges, and that's because the lab and the real world are very different environments. So when we're doing scientific knowledge development and experimentation, we can stabilize the environment and we can focus our inquiry in a very specific clinical context, if you like. So we can cut out the noise. And that enables us to advance in terms of knowledge discovery in a systematic and rigorous way. Now, the trouble is when you get to the real world, our environments that we live in are the opposite of that. So the real world is messy, complex, interactive, and frankly, it is unpredictable. And that means the kinds of real world problems that we encounter in our everyday life are what's called wicked problems. They aren't solvable by a mathematical formula, and we can't really foresee the interactions. And if I do this thing here, how will it affect this other thing? The answer to that is actually we don't know with any sense of estimatable, meaningful probability. So the capacity to harness AI to solve public problems is, I'm afraid, at least in my view, still very limited. So it might be nice to think that we can do it, but only without making some very significant assumptions that don't, in fact, reflect the real world that we live in. So in terms of policy knowledge, to solve big policy problems like climate change and malnutrition and international conflict and how do we deal with displaced persons, I don't think AI is going to get anywhere near providing us with the solutions to those problems because they're messy human problems that arise from the nature of the human condition, I'm afraid, and I don't think the machines are going to let us overcome those problems.
Yeah, that's really interesting. I didn't know where you were going with the answer until the end. One thing I would say is, and I'm very far from being an AI expert, as I'm sure is already clear, but one change that I think I can see is that AI in the last few years has acquired this capacity to kind of range over a huge body of data and make sense of it in a theory-free kind of way. And make sense is the important phrase here. I don't just mean it can like do a transformation, like a processing operation very fast over a huge amount of data. You need computing power for that, but you don't need AI necessarily, or at least a new kind of AI. What I mean is it genuinely can find ways to make sense that we didn't have. So one example that springs to mind right now is an area of my work where I started to rely on AI. And that's in making this podcast, actually. So sometimes after making a recording, I get an audio file from a guest, or my own audio if I set things up badly, which is kind of messy. It has some room noise, it has a siren going past, it has children shouting in the street outside, or it has some microphone artifacts or a weird buzz or whatever. I think even in the last 5 years or so, the way that I've handled that problem has evolved twice. So originally I used to go through the audio manually. When I say manually, I don't mean like with scissors and acetate, but on a computer by interacting with the wave spectrum. I would listen to the audio and I'd hear a police siren or whatever I need to cut out, and I'd go and look at the audio spectrum visually and find a bit that corresponds to the police siren and literally erase it. But then along came the first evolution, which is that it became possible to mark a little bit of the audio as good or bad and then tell the computer, okay, go through the whole file and find all the parts like this and isolate them so you can remove them or enhance them or whatever. So that's a big productivity boost, right? Because the computer now does the work very fast. But it is essentially the same work I was doing with the same, as it were, like theoretical input, the same guidance at the start. It's just way better at it, faster at it than I was. And then we get to what's changed in the past 12 months, which is like a second evolution. And now it's very different. Now all I need to do is take the whole audio and feed it to an AI. And the AI listens to, that's in quotes, right? Listens to the file and figures out that it's a voice and makes sense of all the sounds in it and does a million different operations to the audio whenever it thinks it needs to. And it hands me back what is almost always a beautifully polished, high quality audio recording of just a voice. And so the reason I go into this detail is to try and illustrate what was in my mind when you were just answering that last question, because I thought you might be going to say, okay, these tough policy problems like climate change or malnutrition you mentioned can't be solved just by adding computing power to like iterate an operation we already know, like the way I used to do audio processing, because we don't know the operation we want to do. We need to make sense of the whole big, wicked problem. But maybe they can be addressed by giving the whole wicked problem to an AI and asking it to do not just the processing, but also the interpretation and the sense making, kind of from nothing, which is what we struggle with. But you didn't say that.
Yeah, I'm afraid that you cleaning up your audio is nothing like solving the challenge of malnutrition.
Yeah, good. Fair. So why not?
so, I mean, your example is a really nice one because it involves multiple tasks which have to interact with each other in order to generate your desired outcome. But the task, the overall goal that you're seeking to optimize can actually be formulated into a mathematical problem, and it can be disaggregated into specific mathematical tasks. I don't think that's true of malnutrition, I'm afraid.
All right, but why? I mean, I understand that it's big and complicated, but why does that mean it's not solvable in a kind of classical way? Surely we know the objective we want to get to.
When I say that, I'm going from one very narrow task to a massive, gigantic global problem. And I did that deliberately just to indicate that the nature and the magnitude and the complexity of the challenge of malnutrition. How do we feed the world without people going hungry? In fact, in principle, it should be a solvable problem insofar as I think there are enough resources in the world to feed all of the hungry people. It's just that some people have a lot and some people have almost nothing. So you could say this is a classic optimization problem. And I guess if you just took the humans out of it and you compulsorily redistributed resources, it would be totally doable. But try telling that to the people that have the resources. And so I'm just going to take that from you and I'm going to reallocate it to these people. Do you think that's likely? That's the problem. The problem is always the humans. It's not the maths, it's the humans.
Okay, then taking on board what you just said, I get that solving climate change might not be a tractable problem we can hand over to AI in its entirety. But maybe there are some big elements of it which we could hand over, things that we can't currently do well enough because of the amount of data involved, maybe. So, for instance, modelling the global climate system in really good detail might be one of those things, like good enough that we can predict the impact of changes that might happen or that we might want to try and make. Is that somewhere where AI can help us?
I mean, I think you could more than likely do some modelling with the climate data that we have. But in terms of predicting the future, the trouble is nobody knows the future, and the future of climate change depends partly on what we do as human communities. And you have to make a number of assumptions to build that into your model. And the answer is we don't know. If you'd asked me a few years ago whether we would be in the situation that we see the world in today and the rise of the far right across Europe in the way that we see it, that we see Trump might actually make a comeback, all of these things, frankly, are terrifying. I would not have foreseen them 2 years ago. You have to build that into your climate model because how Trump acts will affect what happens with the climate.
Yeah, okay. Well, in that case, do you think this limitation is well recognised? Because it seems to me there's quite a lot of optimism bouncing around at the moment about how AI will be able to help us solve some of these big problems. Is that overly naive?
I can imagine you can predict my answer to that. Without an AI. No, I don't think it's well recognised because the power of these technologies is wonderful. In a sense, they can accelerate knowledge generation and production processes in radically enhanced ways. But they still haven't solved the problem of the human condition. And short of complete annihilation, I don't think that problem is solvable.
What about knowledge synthesis? This seems to be something else that AI is really quite good at. I mean, from playing around with large language models, I can ask it to give me a summary of the state of science in a particular area, given certain parameters, and it can do a fairly good job. I think this is an important need that policymakers often have. I wonder whether meeting that need is something that AI can take on as a kind of contribution to science advice.
Yeah. So I think in terms of gathering together a whole shed load of stuff, sorting through it, putting it into nice categories and spitting it out in a comprehensible, accessible way, it's getting extraordinarily good at doing that. So I think that is a really useful function that we're already seeing performed in many ways. Now, the problem we do have with that is to understand whether or not they're accurate summaries, whether they're plausible summaries, whether they're meaningful summaries. The machine can't actually tell her. You need human judgment and experience and genuine knowledge to actually make those evaluations, and those the machines cannot do.
Okay, so when it comes to giving scientific advice, it sounds like AI might be a useful tool for the science advisor, but it's not going to replace the science advisor anytime soon, even when it just comes to reviewing the science.
I think that's right. And we already saw that when we were trying to understand the current state of the art in terms of research practice. We found that it was very useful for automating a number of tasks and helping to accelerate scientific discovery in a number of ways, again, quite variable across disciplines. But one thing it could not do was undertake scientific review. It wasn't able to do a meaningful evaluation of quality.
Why not? I mean, in principle, why not? What's the barrier?
In principle, why not? Because, and this is the fundamental problem that I think many people don't grasp, is the machines do not have the capacity to ascribe human meaning and significance to information.
Okay, so say a little bit more about that, because that triggers my philosophy antennae a bit. What is it that you're saying I can do as a human which a machine can't do?
That's a really big question. Let me try and simplify it. That you come to information you come to the world with all of your prejudices and biases and experience and your narrative understanding of yourself and how the world works. So if I made a rude gesture at you, which was really offensive, the machine, I don't expect, would pick that up. Although looking at huge amounts of footage over time, it might recognize that whenever that gesture was made, someone reacted in a way that indicated they were not happy about it. But the machine wouldn't be able to understand the significance of it. And I mean, it's interestingly, this comes up in legal philosophy in terms of what is the law, what is distinctive about the law that distinguishes the law from other kinds of patterns of behavior in the world. And there's a difference between describing the fact that if you were a marshal and you came down into the world and you watched the traffic and you saw that vehicle, when there was a red light, they stopped. And you would be able to make an association between the car stopping and the red light. But you wouldn't understand that the red light means you must stop. You would only see the association, their meaning and significance, you would not understand. And that's the fundamental difference, that human search is for meaning. We want our lives to make sense. We want other people's behaviors, the way we live in communities, to make sense, to add up to something that is worthwhile, that has significance to us as human beings. And the machines, they don't have that. They are wonderful at imitating all sorts of phenomena in the world, but they're fake. They're simulations of our experience. They're not our experience.
Yeah, okay, but hold on a minute. Is that not a kind of philosophical concern that really need not matter in real life? I don't mean this to sound dismissive of philosophical concerns. I mean, my background is also philosophy, but I wonder...
Does it matter?
Yeah, exactly. I mean, we might agree, or we might agree to disagree about whether the AI really understands the meaning of the red light in the way that a human does. But if it can observe a traffic system and notice that cars stop at red lights and internalise what it's learned and use that to design a future traffic system where red lights also have the same impact. Like, why do we really care whether the AI, quote unquote, understands the normative force of the red light? I mean, to ask it a bit more concretely, why does that lack of human style understanding, if that's what it is, stop it from helping us to do things?
So that's a very good question. So it depends upon the problem and the intervention that you want to undertake. So if I said to you, would you like to have a robot girlfriend? Do you want to have a robot girlfriend or would you rather have a real one?
We should be a bit careful here. I think I'm happy with my real human girlfriend, thanks. I mean, I think I prefer the real one. And the reason I prefer the real one, I mean, I can think of some pros and cons of each maybe. But the reason I prefer the real one is I think that I want to feel like I have a girlfriend who is genuinely choosing to spend time with me. Like it's a meaningful choice on her part, not just someone who spends time with me because they're programmed to and is just going to yes and everything I say or everything I do.
And you probably wouldn't want a real girlfriend that said yes to everything you do either.
No, I mean that's the point, right? I mean, if
Right.
she did, I'd at least want it to be part of some kind of meaningful human interaction, not just someone saying yes to try to keep me happy all the time. That's a bit creepy.
Exactly. What you want is meaningful, authentic human connection. The machines are indifferent to that.
Okay, fine. Well, so I'm not going to have an AI girlfriend anytime soon, but I wonder.
Well, you could if you wanted to. It's just that you don't want to.
Well, okay, but that doesn't mean I don't want an AI. I don't know, designing a traffic management system or solving the big problems of the world. It just means I don't want to sleep with one.
No, absolutely. And I'm not, and what I'm not saying is that we should not use AI. AI has enormous potential to do certain things. And for those, bring it on. But we need to understand the limitations. And that is the problem because at the moment it feels like the current rhetoric is the AI will take over and we'll either be annihilated or, we'll sit around and smoke pot and sing kumbaya. Sorry, we've gone very off track, haven't we?
No, no, I mean, it's fun, and I mean it's at least half my fault. But look, the reason I'm asking whether policymakers get this is because at the moment, one very important task for experts like you is to help policymakers to understand the current status of AI and its possibilities. First, to understand whether it can help in their work, and if so, how it can help them. But second, to understand at a meta level how they should be regulating it and dealing with it. That's why I'm asking about their current state of understanding. What's your experience when you interact with policymakers?
That's a really good question. I have been quite involved in the AI policy, the regulation of AI discussions for many years. And it's fair to say that policymakers' familiarity and understanding has improved over time. So, say around about 2015, 2016, policymakers were really coming at this afresh and were inclined to be a little bit like the public now, which is to treat it like pixie dust. The machines can do anything. But over time, they've become, or at least the good policymakers have become a bit more attuned to how the underlying technologies work. But there's still a real problem in that, and I had it myself in trying to understand the technologies better, in thinking that, oh, these machines can learn. And there's a misunderstanding of what that actually means in practice. So sometimes we do have real time online machine learning systems that do, in fact, update in real time. But a lot of machine learning applications are not like that. They're used at the training stage to develop a basic model, and then the model itself is static. So there's no learning that's going on in real time. And that's actually very different, and particularly for risk modeling. Risk modeling about people in particular are based on these kinds of static models that are not getting any feedback about the real world. And so they become really quite blunt and quite dangerous. So I think there's a really fundamental problem in understanding their technology and understanding specific technological applications in their context of use, and therefore understanding their limitations and particular what can go wrong. And it's because these things can go wrong and have unintended effects, negative unintended effects on other people who did not consent to those unintended effects, that regulation is vital.
And this seems to be like a special kind of acute case of the more general problem we have when science and policy interact, that science is complicated and sometimes messy, and the people who work in research aren't always the best at understanding policy needs and communicating things in a way that addresses that. And this seems like a particularly acute case because it is very complicated. There's a lot of misunderstanding and misapprehension in general in the public sphere, and also it's very new, so nobody really has it under their belt at all. Like everyone's still trying to get a grasp on it.
And then there's an additional layer, actually, it is highly political. And that makes the policy space even more challenging to navigate.
How so?
Because, I mean, you will have heard the geopolitical claims that whoever wins the race to AI rules the world. So at the geopolitical level, you hear lots of discussion about the race to be the leaders in AI, that China and US are at the forefront of that Europe is lagging behind. And if we regulate, we will bind our own hands and we will become serfs in the future AI-enabled world. This is a very common narrative that you hear in policy circles, and this narrative of regulation stifles innovation is one that is in the technology industry's interests to push. And it is increasingly in the interests of government to push because they don't want limits on what they do with the technology either. And particularly when in an socio-economic environment of limited resources, AI is portrayed as the kind of savior of our economies that actually will have innovation-led economic growth, and therefore we don't want to stifle these potential entrepreneurs from doing cool stuff that will make us prosperous. So there's a very problematic alliance between governmental and industry interests in which those that have the most to lose have very little voice, and it's very difficult to get their perspective across.
So we have this situation where there's a lot of new knowledge, a lot of new technical stuff emerging and developing that we need to understand. And there is an urgency to regulate it, but to do it intelligently. Most regulators are not experts. And there's also, as you mentioned, this complicated geopolitical dimension, which can sometimes pull us in a different direction. So how do we handle this? How do we make sure that the science and evidence are being well heard and acted on in policy debates?
Yeah, I mean, there's another layer on top of that, and it's inequality in resources. So this is really novel and challenging, is that actually the greatest capacity to utilize these technologies and to extend the boundaries of their capability lies in the private sector. And this, I think, is novel, although I guess if you think back to the turn of the century prior to the Industrial Revolution, we had in the US, for example, the power of railroads, and they wielded an enormous political and economic power. But we were able over time to bring them to heel through antitrust legislation. So this is interesting. And it's interesting that probably one of the most powerful instruments we have to deal with the abuse of monopoly power is through the use of antitrust or competition law, but doesn't really solve the problem of inadequate resources in terms of capability within the public sphere to be a sufficient match, if you like, to generate our own independent, publicly held infrastructure and AI as a common pool resource, as opposed to a privately developed resource for profit extraction.
Okay, so I asked what the solution was, and you gave me a reply which I think was mostly more problems. But the point you made at the end about, well, okay, nationalising is the wrong word maybe, but putting some of these resources back in the public sector. Do you have any hope, or do you see any signs that this is happening, or that it could happen?
I think there's a growing understanding that it's missing.
Mm-hmm.
I don't think we've got to the point yet where there is enough momentum to recognise that it's needed, it's urgent, and importantly, we have to invest our resources.
Mm-hmm. And this is a political issue, is it? Rather than something where there are actual kind of practical, empirical barriers.
Absolutely. All of this is so politically charged. And that has been my experience of working in this policy space. It makes it really fraught and really difficult because, and this is one of the challenges I think for scientists or academics, if you prefer, working in this space, is that you need to try and hold on to what is knowledge, the knowledge and expertise that you have, but also recognize that one needs to be pragmatic and recognize the political context and currents and the limits of what is politically acceptable. So what I might want in my ideal world is not something I could probably advocate for in policy circles because it simply wouldn't be tractable. It wouldn't fly. So it's difficult, and one has to compromise and one has to negotiate multiple stakeholder interests without holding on to those things that we think are baseline. So that, I think, is the challenge for experts like myself working in the field.
Yeah, that's really interesting. So far, we've been talking about policy making and how the evidence gets into it. I wonder if I could ask you also a little bit about the other end of the process, the policy implementation. How well is that being done at the moment with regards to artificial intelligence?
So that's a really good question. And I think it is in the field of policy implementation where there is a lot of excitement and a lot of optimistic belief by both policymakers and tech firms alike that we can automate lots of these fairly standardized tasks in policy delivery. Like, for example, um, identifying who should be entitled to social welfare payments and administering them, or identifying those who might potentially be engaging in social welfare fraud and then flagging them up for investigation, or dangerous people or negligent parents. Why don't we use the data that we have to create cool predictive tools using AI? Because we know that machine learning systems generate much more accurate predictions than old-fashioned statistical tools. And then we can simply crunch the data that we have historically based on who we've identified as past as delinquent, whether that's being a delinquent parent or some other kind of delinquent. And then we can preemptively, predictively identify those who are at high risk and we can intervene before the bad stuff happens. So that's the logic. And this is the logic of commercial enterprise. If I can predict in advance that you're going to want to buy a chocolate bar in the next 30 minutes, then I'll serve you lots of ads of chocolate bars. And this is the application of that commercial, preemptive, predictive logic to the government domain and the administration of public services. And it has been phenomenally misguided, and an enormous amount of harm and wrongdoing has been done to some of the most vulnerable people because of this naive belief that we can build AI predictors to preemptively identify delinquent people. And this, I think, is really pernicious, and we really need to try and halt the onward march of these applications and come to grips with what is at stake before we roll them out at scale to undertake tasks for the administration, particularly of public welfare, without actually taking a clear-eyed view of what is going on.
Yeah, so yes, I mean, this is something that dystopian sci-fi has been written about for decades, isn't it? This idea of like prejudging people and designing societies based on algorithms. But so in a practical sense, when you say it's gone wrong, what's gone wrong? Is it just unethical? I mean, just unethical. Is that your argument? Or are you also saying it doesn't work, it gets the wrong answers?
I think, unfortunately, it's ridiculous naivety about what is actually involved in administering these kinds of systems and decisions in terms of understanding the lives of real people. But importantly, it's an assumption that the historic data tells us everything we need to know. And this is really visible, for example, in terms of so-called recidivism risk prediction, that we can predict who is likely to commit a crime in future based on historic data of that we have in our criminal records. Of course, forgetting that we do not have comprehensive criminal records of every crime that's been committed. And we only have records of those who have been arrested and those who have been convicted, but we don't know those who have not been arrested or for whom the police didn't even bother to look at. So we have, I'm sure, huge amounts of drug offences going on in Canary Wharf, but I bet we don't have huge arrest data that's taken from Canary Wharf. It's not where police are looking. So there are fundamentally flawed assumptions that the historic data tells us everything we need to know, which is fundamentally flawed because actually the historic data tells us where we looked. It doesn't tell us what we need to know. So basing future predictions based on flawed historic data, based on our past prejudice, is only going to reinforce the injustice. And that is precisely what has happened. It's happened in many well-known scandals, the Dutch child benefit scandals in Australia in relation to robo-debt. We've seen that the way in which automation, forget the AI, has ruined people's lives. In the UK, in the Horizon Post Office scandal, we've seen examples of this throughout the US welfare system. I could go on. There are horror stories everywhere. And these are happening to the most vulnerable people that we have in our societies, and we shouldn't be doing it.
Yeah, and the title of the novel I was thinking of has come back to my head, right? This is Minority Report by Philip K. Dick, where there's this system that allows the authorities to predict who is about to commit a crime and intervene to stop them.
And I mean, it doesn't even have to be about who's about to, who's about to do something wrong. It's about who is doing something wrong. And then they've got to prove themselves. And you just think, hang on a minute, what the hell is going on here? And these people are so disempowered, the computer says no, and then they go into a Kafkaesque loop of despair.
I think before we finish, I want to ask you one more thing. You mentioned a while back the analogy of the railroads in the 19th century in the US. And you said this big new power came along, but we managed to tame it. So we did good lawmaking and regulation. I found that interesting because I've heard lots of people try to make analogies about between the advent of AI and these big past technological revolutions, trying to prove that it's going to turn out one way or another. But of course, it strikes me what argument you want to make about how it's going to turn out defines which analogy you choose. Like, is it going to be more like the advent of social media, for instance, or more like the invention of the internet? Or is it more like penicillin or more like tobacco? So what I want to ask you is, what's your sense here about how much we can reason from history to the present day? Or is it really just something completely sui generis where we don't have an obvious historical analogy? We're just going to have to wait and see.
No, I think it's really useful to think about what history can teach us. It's always useful to think about what history can teach us. The trouble is, trying to interpret history in terms of contemporary developments is always challenging. How do we pick out what is salient and what is not salient? And for me, the most powerful analogy that we have is the so-called first industrial revolution. People say that we're going through the second industrial revolution. The first industrial revolution has, in many ways, improved our lives for the better at scale across the world. We live longer, we have better nutrition, we have better health, we have a better quality of life because we are not, just simply trying to eke out our survival. So there's no question that the Industrial Revolution has generated a number of positive welfare gains right across the globe, albeit unevenly distributed. So there's certainly a lesson there. But what we didn't know at the time of its unfolding is that we were ruining the climate. We were simply unfamiliar with the unanticipated systemic negative effects of this new fabulous activity. And that is precisely what is happening again.
And therefore, what? We need to be more careful?
Yeah, that's exactly why we need to take a more sober, clear-eyed view of what are the unintended systemic consequences if we continue along this route unhindered and think about whether that is the future that we want to live in. And if it's not, then the time to act is now.
I can't think of a better place to leave it. So I want to thank you very sincerely for being not only so expert in this topic, but also so versatile in jumping around it and indulging on my flights of fancy. So Professor Karen Yeung, thank you very much indeed.
Otherwise known as being completely random and haphazard.
That also counts.
The Science for Policy podcast is created by the Scientific Advice Mechanism to the European Commission. It's produced and presented by Toby Wardman, with additional editing by Nina Skorczak. The Scientific Advice Mechanism provides evidence-based expertise and policy recommendations to inform policymaking in the European Commission. This podcast is funded by the EU via the SAPEA Consortium. Our theme music is composed by Carlo Alfredo Piatti and performed by Elisaveta Shushenko.